So looking at the process. So why do we do this? Where do we apply it? And how does it work? And then also, what are some of the pitfalls we have to be aware of? So this is a GE CF6, or sorry, CF6-50 engine. Okay, turbofan engine. And you can see here, what are we looking at? What do you guys recognize in that picture? It's a compressor section. Why do you say it's a compressor section? What do you see? You've got all the stuff for the variable guide vanes. You've got the unison rings and the control arms. So this is a common thing, is we need to go in, and that inside of there, between each of those stages, we've got the rotating, compressor blades. We'll need to go in regularly and look at the condition of them. One way to do that is to take it apart, like we did in engines class. We pulled the compressor apart and measured all our little blades and vanes. But obviously that can't be done on wing, and it's very time consuming and expensive. So remote visual inspection allows us to look inside. So what you'll do is you'll go into an NDT manual. You'll see something that looks like this. And what this is basically a roadmap for how to look at different areas. So what it's saying there in that table on the bottom, if you want to look at the 9th stage compressor blades, for instance, I'm just pulling one, just going off the list, 9th stage. It says there are 66 blades. And if you want to look at the leading edge, you go into port, what they have labeled B1-8. So B1-8 is right here. And what that is you would disconnect the bleed duct and you would stick your scope into that bleed duct, right, to go look at the blades. Okay. And then it says if you want to look at the trailing edge, B1-9, well, that's the same location there. Okay, so that's a pretty easy one. What if we want to look at one that's further forward? If we look at stage 4 here, for instance, it says to look at the leading edge, we go to stage 1-3, B1-3, and that's pointing to this little thing here. Any idea what that is? So that's a little threaded boss, a little threaded hole with a plug in it. And it exists specifically for borescope. Okay, that's a borescope port. And if we want to look at the back of that stage 4, we would go B1-4, the one right behind it, which would also allow us to do the front of stage 5. Right? So they build these different ports in. If there's access, the manufacturer tends to have you use the access that's there, like the bleed duct. If there isn't already an access there, then they're going to put in some kind of a port, typically, to be able to see different areas. Okay. So if we put them side by side, you can see this right here. And there's kind of that support. There's that support structure there we can use to help navigate. You can see the same support structure right here. So all those all those borescope ports plugs are right below it down in this area. Okay. We can't really see them as pictures too far out, but you would basically remove one of those plugs and you can stick your borescope in. Okay. Or the bleed duct, it's barely shown on here. I'm trying to remember where it is exactly. You've got, exactly, this is rotated a little bit, so I know there's this duct here, which I believe is this one right here coming off. So not sure exactly. I think we're on kind of the opposite side, but you get that. So there's that roadmap that would be in your NDT manual. And often these can either be contained in a section of your engine manual or your aircraft maintenance manual, or some of your bigger aircraft, there's actually a whole separate non-destructive testing manual that gives you the procedures for these different things. So these procedures are written by engineers, and in NDT, there's 3 levels as you get into it. If you're going to be, if it's a career path you want to go down, there's 3 levels. Level 1 is what most people have if you're performing NDT. It allows you to perform the inspection. Level 2, and perform it and do basic analysis of the results. Level 2 allows you to do detailed analysis of the results. So if you get some results that are inconclusive, you would take them to somebody who's a level 2 in that method, and your level, what you're certified in, is based on the method. So you take them to a level 2 in that method. Level 3, if you're a level 3 NDT technician, that allows you to actually write these procedures. Okay, so you're almost going to play in the lab when you do your self-design projects. You're almost going to play being a level 3 NDT person by coming up with an object and coming up with a procedure to test it. But if you're working at like an airline or an MRO, the highest they typically have on staff is a level 2, unless they have a technical engineering department. Otherwise, the engine manufacturer would have a level 3, or like a third-party independent company that they bring in to help design these procedures would be the level 3 writing. Some others, here's an example of a combustion chamber. So you can see they've put a borescope in this case. They're kind of showing where it is on the whole engine, and then what you're looking at when you're inside. So anyone know, any idea what kind of a hole this is that they might be going through into this combustion chamber? The igniter, yeah, igniter hole. Okay, so you take the igniter out, you go in. Here's your fuel nozzle on the right, with the swirl vanes around it. What are they looking at right now? What's this over here? What's on that side there? So it's, yeah, well, so what they show, what you actually probably are seeing is the nozzle guide vanes. So the guide vanes leading into the first stage. These are the guide vanes right here. And then here, this part over to the left is your first stage turbine blades right here. And you might be able to see the leading edge of those turbine blades as well between some of your guide vanes. But then if you want to get to the back side of them, you'd probably they'd either have borescope ports or some other way to get into between each stage of the turbine section. Okay. So from here, they could inspect the fuel nozzles, the swirl vanes, the combustion liner. If you pull that borescope out a little bit, you can look at the outside surface of the combustion liner, the inside of the case, and then they can look at the nozzle guide vanes, as well as possibly the first stage turbine blades. Okay. Here's some other ports that they show, just kind of an option. What different areas you can look at. So igniter ports, compressor cases, they've got different ports that can come out, items like that, again, just to get to different areas of the engine. Here's what the engine looks like. So, stop. There we go. So here's the engine, and your igniter ports are going to be, in this case, you've got your igniter ports down here. They're in with the fuel nozzles. They're right in this area right here. Okay. So it's, again, that roadmap to kind of help you. So we start looking inside of stuff. Once we start looking inside, then we need to be aware that things aren't always how they appear. Objects aren't always how they appear. So perception is one. So perception is the neurological process. We're going to take an image, we're going to interpret it, and put it in effect. So here's a few examples. So the left one there, you got two people standing on a number on the ground, right? And depending on which way you're looking at it, it can be a 6 or it can be a 9, right? So when you're using a borescope, fiberscope, videoscope, just be aware that, especially with flexible scopes, fiberscopes and videoscopes, that the tip of the scope may, as you bring it around an engine, around a part, it may end up upside down compared to the direction you have your display sitting, right? So sometimes keeping in mind what's up and what's down, and knowing that, so you're not getting confused about the same thing. How about the top right image there? What do we see? Okay, so Dino says 2 faces, or a decoration, or a vase is what a lot of people call the white part. right? So is it two faces in black looking at each other, or is it a white vase in the middle, right? It could be either one. It's both. And then the age-old question of, is the glass half empty or is the glass half full? So are you an optimistic NDT technician, or are you a pessimistic NDT technician? It's up to you. And maybe both are right at some point or another. So things that can affect it, when we talked about detailed visual inspection, I did show some stuff with light, too much light or too little light. One of the things you can have when you're looking at a scope, when you have these things up to your eye, if your light source reflects off of a reflective surface directly back into your eye, you can get something called flashback. And it's just like a flash bulb on a camera where you get the temporary blindness from a bright light. What do you think you would need to do if that's the case? Do you keep inspecting with that eye that's now got a big black spot in the middle of it? Probably want to take a break, let your eyes readjust, get over it. So color can obscure things. So this internal components, a lot of stuff inside engines is gray and black, right? Video scopes often have the ability to change your image between black and white or color, okay? Sometimes black and white's easier to see contrast, right? See dark areas versus lighter areas. Sometimes it's handy to see color because, you get a dark area inside an engine. Is it burning, right? Is it carbon buildup, which is going to appear more black? Is it overheating? What would that appear? What does overheating, particularly titanium, do? Coloration, what color? It gets a blue tint to it, right? So being able to sometimes discern color is good, but at the same time, that can sometimes obscure things. So just keep that in mind. The other thing to keep in mind is the geometry is sometimes going to look obscured in these scopes. So curves, angles, holes, overlaps. Overlaps can be a little confusing to look at sometimes, different layers. So you really got to understand. Sometimes it's nice to have the parts to look at them when they're not installed. If you're gonna be the person doing combustion liner inspections, go see if you can go to the engine shop where they're tearing these things apart and actually look at what a liner looks like not installed in the engine. Or look at what the turbine blades look like when they're not installed in the engine, and give you a little bit better idea of what it is. So when you're looking at these images that are distorted, you can kind of compare it back to what the actual thing is. So other stuff, orientation, we looked at, the two people looking at the number 6 or the number 9. Orientation can make things look a little bit different. Which way is up? Is the scope pointed up? Is the top of the screen up, or is the top of the screen down, or maybe the top of the screen sideways, depending on how the camera gets rotated on the end. A big one is expectations. And that's where I was talking about going in and looking at parts that aren't maybe installed. Have some expectation of what it's supposed to be. Don't let those expectations get in the way of finding something, though. Okay? When we're doing this in class, you are going to find indications on just about every part that I give you, right? Basically every part. The reason we have these parts set aside for NDT is because they have damage that we want you to find and be able to see how things look. If you're out in industry, if you're doing this, what do you think you're going to find 9 out of 10 times or 99 out of 100 times? Nothing. Most of the time you don't find anything, and most of the time you don't want to find anything. But don't get complacent. Don't get so set on, I never find anything. I don't know why I do this, that you miss it when something is actually there to see. Okay. Equipment issues, another thing to look at. So, what's the quality of your equipment? How well is it maintained? Is the light getting dim? Are the electronics working right? Last year, the video scope got dipped into an oil pan and it blurred our video for a period of time until I could get the oil out. Don't know who that was. No idea, Jace. So, just be aware of that. If you get a scope out and it's really oily or really, really blurry, maybe someone got a hold of it and dipped it in an oil pan what were you trying to find? A ring or something? Okay. Throwing them under the bus there. Okay, it's okay. We got it cleaned out. It's not a big deal. So just know that. So just a few kind of like exercises, things to look at. You tell me, which one is different? Guess I should resume. Okay, so D is different. So if you look at these, the kind of just one way to look at them. So if you look kind of the main body, this goes up and then it goes left for 2, right? This one goes up and left for 2. This one goes up and left for 2 with the bottom part coming straight out at you, right? The bottom part's coming straight out here. This goes up and then goes right for 2 on D. And then the other part is at the end of the part coming out. If you look, this kind of goes opposite of the top part to that's going 2. This one down here, this goes right. This bottom part goes straight down. Okay, so they're similar, very similar, but you know, one looks a little different than the rest. Okay, so just be, you know, that kind of thing. Don't, you know, things will look very similar inside of there. Do that. Okay, here's our next one. Are these all the same? And I'm talking about length. So you're looking at the lines. Put them in order. What's the shortest to the longest? What do you think the shortest? What do you think the longest is? So again, C being our shortest. And we got A, then F, then D and E, and finally B being the longest. Here's another thing to look at. How does position affect? Remember, the further away you are from a scope, the smaller things look, so the closer things look together. The distances between items look shorter. So here you have a combustion liner wall or combustion, liner section perpendicular to the wall. You can see the top image here is what it would actually look like. This is where you got those pieces of metal kind of corrugated on top one another, right? And so you can see, and then there's some cooling holes there. And so they show how if you put a borescope in, you know, and you're looking up, and this is what kind of a borescope are we looking at here? You know, remember the name? What? Retrospective. It's looking back. Good job. So our retrospective borescope, looking back the direction we're looking in, you can see at the bottom, it's going to smash those things together, especially those ones that are further, you know, significantly further away from the focal point. And it's going to make those holes look like ovals. Those round holes look oval shape. Okay, so you got to understand that there is some distortion you're going to have to overcome. Okay. How about our next one? What's going on here? My floating rock. Is the rock floating? Think it's a reflection on water? What if I flip it over? Okay. So you've got the floating rock because our camera got turned upside down, or we've got a rock sitting in some muddy water. Okay. So these are all things, you know, we need to keep in mind as we get into, you know, we're starting to look inside of areas. We're looking through tools that can potentially cause some distortion. We're looking at angles and orientations that can cause some disorientation. You got to keep that in mind. And so it's going to take some practice. When you get these scopes, when you pick them up, when you start using them, you'll notice there is a certain amount, there's a learning curve to figuring out where things are at. And one of the things you're going to have to do is I have a box that is called the mystery box. It's got a borescope port, and you have to map out and figure out where everything is in it. And you have to basically sketch a map of what it looks like. And the shapes and certain shapes of items inside of it and orientations of certain items inside of it. You know, what's up and down and what's in front of and behind stuff and what shapes it and so you'll do that as kind of an activity to help you learn to navigate using some of these scopes. Okay. So that wraps up borescopes. Let's go ahead and take a 10-minute break.